Did you know that games aren't random? Nope, they're not random at all. Players think that random is unfair. It feels unfair when you're playing it, so games cheat. Here's one way we're doing it in Rogue Wave. We're using weighted random. We're going to talk a little bit about why you do it, but more importantly, I'm going to show you how to do it, including the code. And that code's open source. Links in the description. In the heart-pounding world of roguelike wave shooters, every round is a dance with danger. Here's the twist. The enemies the player face are not just a random mob. They're carefully selected by weighted random selection. This means that while the player knows which types of adversaries to expect, there's always an element of surprise. Wave definition is key. By mixing up enemy combinations, the game strikes a balance between predictability and unpredictability. The player gets to strategize, planning their moves and weapon choices based on known enemy patterns. But they can't get too comfortable. The random factor keeps them on their toes, ensuring that no two waves are ever quite the same. Now let's talk about progression. Weighted random numbers are the game designer's magic wand. They control the flow, introducing the player to new, tougher enemies at a pace that lets them learn enemy weaknesses without being overwhelmed. It's like a training ground that prepares them for the ultimate showdown without throwing them in at the deep end too soon. With small tweaks to the weights for the enemies, game developers can create just the right level of challenge for all player types. So, how's this handled in Rogue Wave? First we'll look at it in the editor, and then we'll take a peek inside the code. First we have the level definition object. This level definition defines, amongst other things, a number of enemy waves. Each of these waves is defined in an object called a wave definition. This describes what enemies are to be included in each wave. Each enemy in a wave is given a relative weight. This is used to influence the semi-random selection of an enemy whenever a spawn is needed. For example, here we have the level development scene. We're working on level 2 of the game, which is designed to introduce our second enemy. First we create a new wave definition object. We'll call it level 2 wave 1. We add in our two enemies, the gem and the bottle cap. By default, they're both given a weight of 0.5. This means that they're equally likely to spawn. We can see this when we run the game. For every enemy spawned, there's a 50-50 chance that either of them will be created. Let's stop the game and change the weight of the gem. We'll bring it down to 0.1. This will result in the bottle cap being spawned around 5 times more frequently than the gem, because 0.5 is 5 times 0.1. The actual value doesn't matter, it's the relative weights between all the values that are included. So what does this look like in the code? Let's work backwards from the point at which a spawner is deciding which enemy to spawn. Here we see that the spawner is calling current wave get next enemy in order to get the next enemy to spawn. Looking at that method, we see that we're using a weighted enemies variable that must be initialized first. Once initialized, we call a getRandom method on it. We'll come back to that in a moment, but first let's see what this weighted enemies variable is and how it gets initialized. What we see in this code is that we're iterating over a collection of enemy spawn configuration objects, and we're adding them into the weighted enemy variable, which is an instance of the weighted random class, a generic class which in this case is taking enemy spawn configuration objects. It's important to note that we're also passing in a base weight. We'll come back to that later. So what is this enemies variable? So here it is, it's a value that's exposed in the inspector. So this must be the configuration field that we saw earlier. Okay, good. We seem to have most of the pieces now. The only missing piece is what that getRandom method we saw earlier is doing. It's actually pretty simple. It generates a random number between 0 and accumulated weight, whatever that is. It then iterates through its collection of entries to find the one that maps to the random number. Since the weights of these items are all arbitrary values, this means that the odds of any specific item being chosen is directly proportional to the weight of that item in comparison to all the other items in the collection. Great, but where does that accumulated weight come from? Well, if you can remember, we were adding the items into this collection and we were feeding in a weight when we did that. So let's look at that code. What we see here is that it's simply a total weight of all the entries added into the collection. You may have noted, and I did call out earlier, that the weighted random class is actually a generic class. This means that it can be used in any situation where you want to make a weighted random selection. It's used in multiple places in Rogue Wave, such as in the selection of a tile to be placed in the level generator, or the selection of an upgrade to offer on level up. It's a super useful class. You should check it out on GitHub. At this point, we can do all sorts of things with those weights. For example, if the AI director found that the player was having particular difficulty against a specific enemy, it could increase or reduce the weight of that enemy to increase or decrease the pressure on that player at that point in time. So we can tune the game to the individual player. Weighted random selections are an essential piece of the Game Developer Toolkit. I hope you can put them to good use.